In this video, still on circular motion, we are going to be solving the problem on the board now. In our last video on circular motion, we proved a few formulas that are very useful in solving questions of circular motion, okay? And here is an example. Now, in this question, is a body is attached to a string, okay? And it is rotated or forced into motion in such a way that it forms a horizontal circle, which is still on circular motion, okay? We're having a conical shape here when we draw the free body diagram. Now, the mass of the body is given 10 kilograms. The radius formed is given as 4 meters, which is from here to here, which is the radius of the circle. And then we have the speed moving at uniform speed of 5 meters per second. Okay. Now, we're asked to calculate the angle of inclination to the vertical, that is theta. And we're also asked to find the tension in the string. Okay. How are we going to solve a problem like this? It's quite easy. Okay. It won't take up to 5 minutes to solve a problem like this. Now, here is the solution. The angle of inclination to the vertical is denoted as theta. To do this, we're going to extract this triangular part out of the shape. Okay? By bringing out this triangular part, we're going to have something like this. Now, the weight of the body, which is mg, will be equal to the other vertical component in this case. That is the force that will be acting on this place. So any force that is acting down will be equal to the force that is acting upward. So I can come here and then I'm going to write mg, and then here is already the tension, okay, for the string. So we're having T as the tension, and then of course on the horizontal part we're having the centripetal force. So centripetal force will equal Fc. Okay, now those are the parameters we need. Next thing, we are asked to find the angle of inclination. We then have to find the value of T, mg, and Fc in order for us to make use of some trigonometrical formulas to find the angle theta. Now, first of all, you might want to find the centripetal force. Okay. Now, to find centripetal force is simply mass times acceleration. Okay. Where this acceleration is the centripetal acceleration. In our previous video, if you've not watched that video, please go back and watch it so you know how we arrived at this formula. Okay, the formula I'm about to write, which is AC for centripetal acceleration. Now, we did assume that centripetal acceleration is v squared over r or w squared r, which you can just substitute to give us Fc equals mv squared over r or mw squared r. Okay, but what you want to ask yourself, is this enough for us to find the angle? Is it? Okay, we don't know yet. Now let's first of all solve for the weight. Okay, the weight is equal to mg, w equals mg. The mass was given, okay, as 10 kg multiplied by acceleration to gravity is a constant. Okay, let's make use of 9.8. So when we do the math, we are going to get 10 times 9.8. That gives you 98 newtons as that of the weight. Now to obtain the weight, we need one of these two. Okay, now how do we find Fc so that we can make use of this this side mg and Fc to find the angle? We've already put the formula, which is mw squared r. But do we know w? We do not know. Now, we can make use of this one. The only reason we're not making of this one is because we don't know the value of w, which is omega, that is angular velocity. Okay? We do not know the value of omega, but we're giving m and r from the equation, from the question, m as 10, r as 4. But we don't know the value of what now? This guy, so we cannot make use of this formula. Let's come to this. We are giving m and r. How about v? V in this case is the speed or velocity, which was given as 5 meters per second. Okay, so it's given as 5 meters per second. So we can choose to substitute into this guy and solve for Fc. Hence, Fc will be equal to m is 10. Velocity was given as 5, so we have squared, divided by the radius is 4. Okay, so 5 squared is 25 times 10, that's 250 over 4. Okay, so when you do the maths for 250 divided by 4, we're going to have a value of 62.5. Okay, that is not all. Next, let's find the angle theta. Now, to find the angle theta, we'll make use of our SOHCAHTOA. Okay, SOHCAHTOA. Now, we're having this side, which is in this case the adjacent. The side facing the angle is the opposite. Okay, so having the adjacent and the opposite. So which of these ones connect the adjacent and opposite? We can say that we have adjacent here and opposite, so we make use of what now? Tan theta. So tan of that angle, tan theta, is adjacent over opposite. So tan of theta will equal, what is our adjacent in this case? Mg, which is the width, 62.5 over our opposite gives us 98. Okay, so theta is the tan inverse of 62.5 divided by 98. Now when you work that out, tan inverse of 62.5 divided by 98, okay, 62.5 divided by 98, what we obtain is that the angle of inclination is equal to 32.53 degrees, okay, to 2 decimal places. So that is how we solve for the angle of inclination. Now the question also said we should find the tension in the string. We could as well make use of the so-called formula to find the tension in the string, or we could make use of the Pythagoras theorem. From this triangle, we're having a right angle triangle, okay, because this one is perpendicular to the horizontal line. So we can say that t square, which is the longest side, is equal to the square of the sum of the other two sides. So we have mg squared plus fc squared. So t equals the square root of mg squared plus fc squared. So we have t equals square root of, now mg is equal to what? The weight, which we've already solved for, that's 98. So you have 98 squared plus fc, we've also solved for it as 62.5 squared. So when you do the math, we're going to have square root of 98 squared plus 62.5 squared. What we are going to obtain is that the tension equals 116.23 newtons. Okay, so that is how we find or we solve for the tension. Okay, so it's quite easy. First things first, we have to draw the free body diagram from the question, of which in this question it was given actually. Okay, and then the next thing we're going to do is bring out this small triangle and then make some analysis on it. It is very important for you to have basic knowledge on trigonometry, as it makes it very easy for us to solve what now, as the angle of inclination as well as the angle, as well as the what now, tension acting on the string. Okay, so it's quite easy. And in our next few examples of videos, we'll be taking a few examples still on circular motion. So do well to like, share and subscribe. Okay, click on the notification bell so that when a new video is uploaded, you'll be one of the first persons that get notified. See you in the next video.